In this tutorial video, I shall explain some questions from chapter Surface Area and Volume and exercise 13.1. So watch the complete video. Let us consider the very first question of this exercise. A plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is to be open at the top. Ignoring the thickness of the plastic sheet, determine the area of sheet required for making the box. And the second question is the cost of sheet for it if a sheet measuring 1 meter square cost rupees 20. Now, according to the question, we have to consider a plastic box whose top is open. So let us consider this plastic box. The top of this plastic box is not there. So we can say that it is an open box. Length of this plastic box is given 1.5 meter. Breadth is given 1.25 meter, while the depth of plastic box is given 65 centimeter. When we convert 65 centimeter into meter, then it will be equals to 0.65 meter. So let us see the solution of this question. First of all, we have to take the value of L, means length is equals to 1.5 meter, breadth is equals to 1.25 meter and height is given in the question 65 centimeter. After converting it into the meter, then we will have 0.65 meter. Since this plastic box is not having the top, so we have to find out the area of only 5 surfaces, only 5 faces we can say. So we can write here, since the box is open at the top, so it has only 5 faces. So the surface area of the box will be equal to the area of 4 walls, area of this 4 walls. First wall, this is the second wall, this is the third wall and this is the fourth wall. We have to find out the area of all the 4 walls plus area of this base also. So here we can write surface area of the box will be equals to area of base, that is equals to L into B. Area of base will be equals to L into B plus area of 4 walls. The formula of area of 4 walls we can use 2 under bracket B into H plus H into L. Instead of writing this formula, we can use another formula also, 2 under bracket L plus B into H also. After writing this formula, then we have to put the value of length, breadth and height. Let us see, when we will put the value of L, B and H, then what is the next line? Length is equals to 1.5 meter. It is already given here in the question. Breadth is 1.25 meter. And here again we have to put the value of breadth, value of height, value of height, value of length also. After calculating this one, the product of 1.5 and 1.25 will be equals to 1.875 meter square, and when we will evaluate this line, this will be equals to 1.7875. Now after adding all these things, then we will have the final value equals to 5.45 meter square. It means that we need 5.45 meter square of plastic to make this box. So the final answer of the very first question is 5.45 meter square of sheet is required. Now in the second question, we have to find out the cost of sheet for it if the sheet measuring 1 meter square cost rupees 20. Since the cost of 1 meter square of the sheet is equals to rupees 20, so here we have to write, since the cost of 1 meter square of sheet is equals to rupees 20, hence the cost of 5.45 meter square will be equals to 20 multiplied by 5.45, and the final answer of the second question is 109 rupees. Now let us consider question number 3. The floor of a rectangular hall has a perimeter 250 meter. If the cost of painting the four walls at the rate of rupees 10 per meter square is rupees 15,000. Find the height of the hall. So, according to the question, first of all, we have to consider a figure. Let us consider this figure. This figure is representing a rectangular hall whose length is L, breadth is B, while the height is H. So first of all, we have to assume that let the length of the rectangular hall be L, breadth is equals to B, and the height of the hall is H. So in the solution, the very first line will be let length, breadth and height of the hall be L, B and H respectively. Now let us see the very first line of the question. The floor of a rectangular hall has a perimeter 250 meter. So in the second line we can write here perimeter of the floor of the hall is 250 meter. As we know, the perimeter is always equal to the 2 under bracket L plus B. So here we can write perimeter of the floor of the hall is equals to 2 under bracket L plus B, and the value of perimeter is given 250 meter. So we have to write here 250 meter. It means that 2 under bracket L plus B is equals to 250 meter. This 2 L plus B is representing the perimeter of the floor. Now, according to the next line, if the cost of painting the four walls at the rate of rupees 10 per meter square is rupees 15,000. It means that if we divide the total cost by the unit cost, then we can find out the area of four walls. So in the next line, we can write down area of four walls of the hall will be equals to 2 under bracket L plus B into H. This can be equation number 1. As we know, the area of four walls of the hall is always equals to 2 under bracket L plus B into H. But according to the question, the total cost of painting is given 15,000, but the cost per meter is also given rupees 10. So here if we will divide the total cost by the unit cost, then also we will get the area of four walls. So the next line we can write here, also the area of the four walls of the hall is equal to 15,000 divided by 10 meter square. When we will divide these two, then we will have 1500 meter square. This can be equation number 2. In equation number 1, we are having area of four walls of the hall is equals to 2 under bracket L plus B into H. In the second equation, we are having area of four walls of the hall is equals to 1500 meter square. So from equation 1 and 2, we can say that 2 under bracket L plus B into H is equals to 1500 meter square. So here we can write 2 under bracket L plus B into H is equals to 1500. 2L plus B into H is representing the area of four walls, and this 1500 is also equals to the area of four walls. Now the next line, 2L plus B into H. The value of 2L plus B into H is given 250 meter. So on the place of this one, we can assign 250. The value of H is not given, that we have to calculate. So on the place of H, we can write H. There will be no change. Now equals to 1500. After that, H will be equals to 1500 divided by 250, that is equals to 6 meter. Hence, H is representing the height of this hall. So we can write here, hence the height of the hall is 6 meter. So this is the final solution of this question. Now let us consider question number 6. A small indoor greenhouse herbarium is made entirely of glass panes, including base, held together with tape. It is 30 centimeter long, 25 centimeter wide and 25 centimeter high. What is the area of the glass? And the second question is how much of tape is needed for all the 12 edges. So in this question, first of all, we have to consider a greenhouse, or in another word, we can say herbarium. So let us consider a greenhouse. In this greenhouse, the length of this greenhouse is given 30 centimeter, breadth of this greenhouse is given 25 centimeter, while the height of this greenhouse is given 25 centimeter. So in the solution, first of all, we have to write down, let the length of this greenhouse is equals to 30 centimeter, breadth equals to 25 centimeter, and height is equals to 25 centimeter. Now let us see the very first question. In the very first question, it is given that what is the area of the glass needed to make this greenhouse. Since this greenhouse is closed and it contains all the 6 surfaces, or we can say 6 faces. So here we have to find out the total surface area of this greenhouse. So here we have to write total surface area of herbarium will be equals to 2 under bracket LB plus BH plus HL. This is the formula to calculate the total surface area of any cuboidal shape. After that, we have to put the value of length, breadth and height in this formula. So after putting, we will get this equation, because the length is given 30, breadth is given 25 and height is also given 25 centimeter. When we will calculate this, then we will have 2 multiplied by 750 plus 625 plus 750, and finally we will have 4250 centimeter square. Hence, the area of glass needed to make this herbarium will be equals to 4250 centimeter square. So this is the answer of the very first question. In the second question, it is given that how much of tape is needed for all the 12 edges. As we know, a cuboid contains 12 edges, means 4 length, 4 breadth and 4 heights. Let us consider here, this is the first edge, this is the second edge, this is the third edge, and behind that one we are having the fourth edge. So 4 lengths, 4 breadths and 4 heights. So to find out the length of tape, we have to write the formula. Length of tape required will be equals to 4 multiplied by length, 4 multiplied by breadth, 4 multiplied by height also. After that, we have to put the value of length, breadth and height. As the length is given 30 centimeter, breadth is given 25 centimeter and height is given 25 centimeter. So we can put the value here, and after solving this one, we will have 320 centimeter. So this is the final solution of this question. Now let us consider question number 7. Shanti Sweets stall was placing an order for making cardboard boxes for packing their sweets. 2 sizes of boxes were required. The bigger of dimensions 25 centimeter, 20 centimeter and 5 centimeter, and the smaller of dimensions 15 centimeter by 12 centimeter by 5 centimeter. For all the overlaps, 5% of the total surface area is required extra. If the cost of the cardboard is rupees 4 for 1000 centimeter square, find the cost of cardboard required for supplying 250 boxes of each kind. So according to the question, we have to find out the total cost of the cardboard required for supplying 250 boxes of each kind. In this question, the dimension of 2 different boxes are given. So first of all, we have to consider the box which is big in size. So according to the question, the bigger of dimension is given 25 centimeter, 20 centimeter and 5 centimeter. So let us consider a bigger box whose length is 25 centimeter, breadth is 20 centimeter, while the height is 5 centimeter. So in the solution, first of all, we have to write down the dimension of this box. Here we can write for bigger boxes, length equals to 25 centimeter, breadth equals to 20 centimeter, and height equals to 5 centimeter. Since this is the closed box, hence it contains all the 6 faces or surfaces. So we have to find out the total surface area of this box. The total surface area of this box will gives us the area of the cardboard required to make one big box. So here we can write total surface area of one bigger box is equals to 2 under bracket L into B, B into H plus H into L. This is the formula of total surface area. After that, we have to put the value of length, breadth and height. After putting the value, we will have 2 under bracket 25 into 20 plus 20 into 5 plus 5 into 25 centimeter square. Now when we will solve this equation, then we will have 1450 centimeter square. To make one big box, we need 1450 centimeter square of cardboard. But according to the question, for all the overlaps, 5% of the total surface area is required extra. Means for each box, we need 5% extra cardboard. For that, we have to calculate 5% extra cardboard for each box. So area of cardboard required for overlaps, we have to calculate, that is given 5% of 1450 centimeter square, means 5% of total surface area. The total surface area we have calculated here 1450 centimeter square. So we have to calculate 5% of 1450 centimeter square, that will be equals to 72.5 centimeter square. It means that to make one bigger box, we need the sum of these two cardboards. So here we can write total area of cardboard needed for one bigger box will be equals to 1450 centimeter square plus 72 centimeter square, and that will be equals to 1522.5 centimeter square. It means that to make one bigger box, we need 1522.5 centimeter square of cardboard. How many big boxes has to form? We need to make 250 boxes of each kind. Hence, to find the area of cardboard needed for 250 boxes, we have to multiply the area of cardboard needed for one box with 250. So here we can write total area of cardboard needed for 250 bigger boxes will be equals to 1522.5 multiplied by 250. That will be equals to 3,80,625 centimeter square. Now, in the same way, we have to calculate the total area of cardboard needed for 250 small boxes. So let us see how to calculate that. For smaller boxes, length is equals to 15 centimeter, that is already given in the question. Breadth is 12 centimeter and height is 5 centimeter. So let us consider the box. Suppose this is the small box of the suite whose length is given 15 centimeter, breadth is given 12 centimeter and height is given 5 centimeter. So first of all, again we have to calculate the total surface area of this small box. That will be equals to 2 under bracket LB plus BS plus HL. The formula will remain same. So here we can write the formula. After writing this formula, then we have to put the value of length, breadth and height. After putting the value of length, breadth and height, then we have to calculate this and the final value we will have 630 centimeter square. After that, we have to calculate the area of cardboard required for overlaps, as we have calculated for the bigger box also. So 5%, we have to calculate 5% of the total surface area. So 5% of 630 centimeter square will be equals to 31.5 centimeters square. After that, we have to add these two areas together, because if we will add these two areas, then this will returns us the area of cardboard needed for making one small box. So here we can write the total area of cardboard needed for one smaller box is equals to 630 plus 31.5 centimeter square, that will be equals to 661.5 centimeter square. Again, here we have to make 250 boxes, 250 smaller boxes. So we have to calculate the total area of the cardboard needed for 250 smaller boxes. So here we can write total area of cardboard needed for 250 smaller boxes will be equals to 661.5 into 250 centimeter square, and the final value is 1,65,375 centimeter square. Now, after that, we have to add the area of both the cardboard. This is the area of cardboard needed to make the smaller boxes, and in the previous one, we have calculated the area of cardboard needed to make the bigger boxes. So, we have to add both. Here we can write total area of cardboard needed for 500 boxes, 250 bigger boxes and 250 smaller boxes. The area of 250 bigger boxes were 3,80,625, and here we have calculated the area of smaller boxes is 1,65,375. That will be equals to 5,46,000 centimeter square. According to the question, the cost of 1000 centimeter square of cardboard is rupees 4. Hence, the cost of 1 centimeter square of cardboard will be equals to 4 upon 1000. Hence, we have to find out the cost of 5,46,000 centimeter square. So, cost of 5,46,000 centimeter square of cardboard will be equals to 4 upon 1000 multiplied by 5,46,000, that will be equals to 2,184 rupees. So this is the final solution of this question. Thank you for watching this video.